Okay, so my name is Matt Deegan from the Australian Meat Processor Corporation, and I'm the Program Manager for the Sustainability Program. And my role today is to talk about red meat processors and their role in advancing the circular economy. So the first thing to talk about is, first of all, I'd like to thank Fabiana for arranging this session today. She's done a great job, particularly in getting a variety of different attendees, which is what the circular economy is all about. So thanks, Fabiana, and also congratulations on your recent award, winning the WA Water Professional Award. And particularly thank you to the attendees today in Albany, WA for attending in person. So the Australian Meat Processor Corporation, we're the Rural Research and Development Corporation supporting the red meat processing sector in Australia. And our mandate is to provide research, development and extension services that improve the sustainability and efficiency of our sector. Our programs deliver outcomes and benefits for both the processing sector and the broader Australian community. When we talk about Australian red meat processors, there is a long history. Processors have been advancing value for the red meat industry since 1886, when the first shipment of red meat left Australia for London. To 135 years later, processors are now still using ingenuity and good management to manufacture and deliver around 2.75 million tonnes per annum of quality red meat produce to markets in 100 different countries. And they do this without incurring any food waste on their sites. And that was confirmed by an independent report, third-party report this year, known as the National Food Waste Strategy Feasibility Study by the Food and Agribusiness Growth Centre, otherwise known as FIAL. Just like to mention that because to do what they do with the volumes they handle and incur no food waste on site, that is a remarkable achievement in terms of ingenuity and good management. The economic contribution that red meat processors make to Australia is clear. Australia is a key exporter of global red meat markets. Last year, Australia was the second largest beef exporter after Brazil, and Australia is the world's largest sheep and goat meat exporter. Australia's red meat and livestock industry adds 17.1 billion to GDP, and the red meat processor sector employs over 30,000 people. That accounts for about 1/3 of total employment in agriculture, forestry and fishing. And nearly 80% of meat processing employment is located outside of capital cities, so very much community-driven types of businesses. So the other important thing with economic contribution is that more than 60% of total red meat products are exported to countries overseas. When we talk about our members, there is no such thing as average. So when it comes to advancing value for the red meat industry, there are a number of different types of businesses. I don't think any two are the same. So we have 106 members operating across Australia, and between them, they operate 135 processing facilities. And as you can see there, if we look at beef on the left and then small stock being sheep and goat on the right, there are 71 plants processing beef and about 50 plants operating small stock. In terms of size, for the beef, there are 11% of processors are termed as large, and a lot of processors, this is both for beef and sheep, a lot of processors in the small and micro area, but when it comes to throughput, clearly the large ones have the majority of the throughput for both beef and sheep and goat. And that says that there is really no average type of member. Some of those smaller processes, doing what they do for very niche markets in their own local area. Some of the larger ones, of course, are satisfying markets in other countries, but all of them have a reason to exist and they all do a great job. The red meat processes are very diverse. So as far as employers, our members range in size from two employees to 2,000. So that's quite diverse. A whole range of different people from different backgrounds, different cultures, different training. Half of our members have less than 200 employees. It's quite an array of different types of products and processing sizes, as I've mentioned, covering those different types of species. Cattle processing is the most common, represents about 83% of all member sites are in cattle processing. And there's a real geographic diversity as well. So members are spread throughout Australia. Very proud of our Western Australian members, of course, and AMPC members are primarily located in areas, rural areas and regional areas with populations of between 10,000 to 50,000 people. The other thing with red meat processors is they're very collaborative. This is because they are so diverse in their workforces. They have a whole range of different types of skills that they offer in science, technology, engineering, human resources, financial management, marketing, logistics. So red meat processes are incredibly diverse in terms of skills, which enables them to be collaborative across their communities. So they do play a specialised role in the supply chain. And our role is to help them find the right opportunities to collaborate with stakeholders to provide those value-added opportunities. As indication of environmental collaborations we've got going, we're a supporting partner of the Waste to Profit program, which is primarily supported by the Australian government and MLA, but there are a number of other entities, RDCs from different sectors that we collaborate with, as well as different businesses across industry. So other RDCs such as dairy and pork and a number of tertiary institutions, as you can see, as well as some utilities as well. So the Waste to Profits program has been running for almost 4 years, and that's been a really good collaboration of environmental directed projects. In addition to Waste to Profit, there's the Agricultural Innovation Australia program, which is a new program of which AMPC is a founding partner, and also the Future Drought Fund, of which we are a partner of the Drought Resilience Hub in Queensland. So the sustainability program for AMPC helps our members across 5 different areas. Communities is a particularly important area: energy, water, waste, and packaging. So they're the 5 areas in the portfolio. Some of those areas, such as energy, water, and waste, are very closely tied together. For example, water and waste, or energy and waste. So it's sometimes hard to differentiate whether they are energy or whether they are waste, but there's often a crossover. With communities, there's a particular focus around our disclosure of our biannual environmental performance review, which illustrates our performance on our intensity for energy, water, and waste. And in addition to that, we have further work that we're looking at in terms of social impact. Going on to some bioenergy projects that Kim mentioned, that bioenergy was a particular focus. It is for us as well. So I've just like to call out 2 projects that we're working on at the moment, which are in the bioenergy area. So bioenergy is particularly important for us because combustion of fossil fuels for process heat is the hardest to abate emission for all food manufacturers, not just for red meat processors. And the future cost and reliability of fossil fuel is under threat in the future. So we have we're building projects that help confidence and capability in using wastes and renewable fuels for the purpose of creating thermal energy. Two of those in particular, one is a containerised pilot project, which is providing options for utilising and testing multi-fuel biomass. So in other words, renewable solid fuels. And then the second one is an assessment and design of modular wastewater treatment. So assistance for members considering gaseous renewable fuels such as biogas. That first project there, that image shows a test boiler. That's not a full-size boiler. What that pilot project is about is making available a test boiler for members so that they can try different forms of biomass through that boiler and look at the outputs such as calorific value, performance, etc., moisture, its ability to handle moisture, etc. So, for example, members in WA will be participating in this project and they'll be trying different types of biomass waste on their site, as well as mixing that with solid fuels from their, such as forestry residues, etc., from nearby local providers. As far as the second project is concerned, that second image there you can see, which is a modular wastewater treatment image. It's not, that's an overseas image. It doesn't happen in Australia in our sector at the moment, but this project is around the assessment and design of that type of project to reduce the footprint of wastewater treatment for our members. So these objectives are around reducing not only the footprint for waste treatment, but also the cost of thermal energy, and to help reduce the emissions profile from process heat. And the circular economy approach is one whereby we'll help our members to source biomass from other sectors, such as forestry, and then look at returning biosolids and digestates to help those sectors, that such as those digestates that would be available from anaerobic digestion. So the circular economy approach for us, these themes keep coming up for us that we're continually working on as far as the circular economy is concerned. So the first one that Kim mentioned obviously was around mapping, very important for us as well. And there's an image of that, like a mapping extract from the ARIMI tool that Kim was talking about. That one in particular in southwestern WA shows a bunch of red dots there around Albany, for example, that come from hardwood forestry products, particularly useful for biomass in that area. But we're also looking at mapping our own wastes, for example, what biomass we have on site that we can utilise not only ourselves, but any biosolids, for example, that can be utilised by other sectors. So mapping is particularly important as far as that's concerned. Then we move on to assessment. After we've identified some hotspots in terms of mapping, what can we make out of those available resources, which leads on to design. The use of modular technology that Fabiana was talking about at the beginning of her presentation. As you can see, there's some images that we're working on at the moment through an online digital tool that will help our processors to work out which modular technologies are best in their particular situation. And then once the full process has been worked up and the solution's been worked up, then identifying the co-benefits that are available, not just the benefits to our members, but also co-benefits to their immediate communities. And that's the process that we look at when we're advancing value, particularly, and that's our role as far as red meat processors are concerned in advancing value in the circular economy. And I'd like to hand back to you, Fabiana.
Thank you, Matt. That was really good. And it's really good to see how the meat industry is being so proactive on really making things differently, right? And it's not that meat is always the bad one. So what I thought would be useful here is, I'm present here, I'm not online. Unfortunately, with the borders and everything, it's so hard to have all the presenters here, right? So what I thought was to talk more in the concept, how this could work and how this looks like in other places, right? So here is just an image where you can see the integration between, let me see. You can see the integration between all the cycles of production. So you have the consumers at the supermarket buying their food, and then they produce food waste that go to a waste at the treatment plant. And then you have the cattle and you have the abattoirs. And all this is part of one big cycle, right? So you produce all these waste and wastewater, and then that could be being used as a bio-based fertilizer to go back into either reforesting or crops. And by combining all sectors of economy is where we have the best outcome. So when we have the utilities working together with the food industry, working together with the fertilizer producers and the farmers. And so everybody's, instead of looking at their own small little problem and struggling with that, everybody's working together to achieve the outcome, right? And fortunately, I'm really happy I managed to get in this room here, people from many different areas. We are also talking to CSPP and to other fertilizer producers on how they could use the biodigestate to produce a commercial fertilizer that's viable and it's safe for the environment as well and for public health. It's not just dumping biodigestate on the land. It's very well engineered. We also are talking to Greening Australia, and I know they are watching us online on how to use that for carbon offsetting forests and you know, managing soil for those kind of projects. So it's a full integrated approach. It's not just looking at environmental compliance of individual abattoirs, right? And we also have in the room here equipment suppliers and service providers that are willing even to finance this kind of projects. It's not that we do have the money, the technology, the waste, the users. So I think we do have the entire cycle here. So working together is very important, right? So I'm going to go through a few success stories, which means people that have been doing that for a while and how they're doing and how they're, what are the struggles and how they're going about it. I was lucky enough that in 2018, I was financed by Harvey Beef and MLA to go to Europe and visit the benchmark facilities, what they're doing there for meat industry and co-digestion. So all the facilities I'm presenting here, I've been there personally, and I've seen it and I've spoken to the guys. And that's where I got so fired up literally on how could we bring this maybe to Western Australia, right? So the first one, I think this facility is very, very similar to Albany case. There are lots of similarities here in terms of economy and the region, and a little bit in terms of the volume of waste. So this facility started with one abattoir. So there was like Fletcher's here alone, right, in town. Then they decided to start working together with, it was more like an organic thing. They had the biodigester operating for the abattoir, and then next farmer came around and said, can I check my waste there, mate? And then they start working together. And then they started working with the local utility, let's say the Water Corp, to receive their sludges. And then at the moment they are processing about 100,000 tons of waste per year. They are generating a lot of energy. But the interesting thing is that they are not producing electricity. They are using the energy for fueling the local bus public transport freight. So they are decarbonizing the local public transport by using the biogas produced by the wastes in the locality. So can you see how many similarities you have from Albany here? Things that you want to achieve in terms of lowering emissions and solving the environmental problem as well at the same time, right? So basically in this facility, they mix the food waste from restaurants, from supermarkets, from agriculture production, dairy, other kinds of industries. They have beer as well there, like breweries and wineries. Slaughterhouses, which is about 30% of the waste, and then other waste from alcohol, from glycol, from fats, from different chemical processes there. So the interesting thing, and I think, well, the process basically it's, we have a hydrolysis and then you have the digestion. And the end product is the biogas, right? And the biofertilizer. But I think this is the most significant graphic I wanted to show today. Is you can see from the beginning, the first few years of operation, they had predominantly just abattoir waste with a little bit of other wastes, right? But then when you look there at 2011, more or less 2011, they started in the same infrastructure, same facility to receive other wastes, receive more food waste, more variety of waste. And look how much the biogas production increased just by, in the same facility, just by operating with combined waste. So that's why we are really advocating for co-digestion and for collaboration. Is you have a better outcome from the same infrastructure. So the same investment, you kind of almost double the benefit, right? So that's what I thought here. We have abattoirs, we have dairy, we have grapes, we have organics still going to landfill. And if we could put all this together, right, and have a really good outcome. And the other thing, we still have a landfill here that will produce gas for probably 20 years still. Even if we stop putting waste there today, we still have that backlog there. Why cannot combine that gas as well with this gas and make it even a higher scale, right? So this is how it looks like in Sweden. They have the gas stations, biogas, how they call it, which people can just go there and fuel with the biogas and the buses. It looks really neat, right? It looks pretty. And that's where I start thinking that paradigm shift of when waste is not waste anymore. Waste is something that brings us value, brings us benefit. It's not only about environmental compliance, it's not only about making money, it's about the integration and getting value from other things, right? So yeah, I think it's pretty amazing. So I visited there, and they do have also, together with the biodigester, they have a sort of a TAFE where they also capacitate people. So imagine how cool it would be, let's say the agriculture school here in Albany, having a dedicated course teaching people how to operate the systems or how to implement them, and how, you know, being like a center of reference nationally. Why not, right? And that's the way I see things. The next facility I want to talk about is they call it the Magic Factory. It's in the middle of Oslo in Norway. So it's not far away from town. It's not hiding. It's not isolated. It's pretty much the opposite. The Magic Factory is like a tourist attraction in Oslo now. So if you go to visit Norway, it's part of the things you do. You go to see the gap and you go to see the waste facility. It is and how they manage waste, right? So I find it super fascinating. It's driven mainly by an abattoir that's locally there. So they give the most of the energetic content, but then food waste and agricultural waste, same thing, producing gas. And so in this case, they use the gas to decarbonize the gas network. So let's say here you have the gas network. So instead of using pure and natural gas, you can inject biogas. So you reduce your carbon footprint of your network. So here you can see that's their website. So you can go there and register for a visit, and they take you around and show you. And this is also integrated with a wider sustainability initiative from Oslo. So they show you also how they build sustainable buildings using more timber. So they are decarbonizing the construction, and then how they recycle water. So it's part of a comprehensive tour on sustainability, right? So that's what I'm thinking, you know, when I'm talking about bringing value to waste, instead of hiding it, chucking it somewhere nobody can see, putting a massive protection zone around it, and oh, it's waste, I don't want to see it. How about we embrace it and we say, oh, this is how we manage waste. This is how positive these things can become, right? And well, this is the vision I have. And yeah, I remember saying that to the guys in the Southwest Alliance last year when we were discussing the Bunbury Outer Ring Road project. And they were saying, you are crazy making a tourist facility from waste. But I don't think so. I don't think I'm crazy. I think it's kind of cool. And then bringing it a little bit more to the Australian reality, we have Yarra Valley. So Yarra Valley just commissioned that recently. This plant, they built that in 2017, and that was commissioned probably 2019. They have a co-digestion facility as well, which started only with their sludges from their wastewater treatment plants. And then they again started including co-digestion. So they brought food waste, they brought the local dairy and wineries. So they end up making a much bigger project, right? So this is more or less how it works. So they have the digesters, they have the fertilizers, they have recycled water and electricity. So they run the Yarra Valley wastewater treatment plant fully on the biogas that they are producing here with the co-digestion facility. And they still have a surplus that is going away to the grid, okay? So that's quite significant. You can run an entire wastewater treatment plant, especially Water Corp wanting to decarbonize as well, right? So, and that's, well, when we speak to Water Corp about that mainly, they'll say, oh, we don't have scale, we are too small. But that's because they're only looking at their own sludge. But how about you open that and then you receive all these other sludges, and then again, you get scale, right? Yarra Valley is also going a little bit beyond that. I think Pat McCarthy, who is the chairman there, he's very, very aware of circular economy. So they also, the land that they have as the buffer zone, they converted that into a farm. So they are using the water, the recycled water, they are using the biofertilizer to produce food crops around as a buffer zone for the wastewater treatment plant. Instead of planting just bush and forest, it is a farm. And then they also have a TAFE there on sustainable agriculture. So they are including the local society. There is a strong Aboriginal presence there as well. So they are capacitating younger people to work on that area, right? Both in operating the waste management and energy production, and also the farming and the food production, the whole thing, which I think is a beautiful example, right? It's something that I can believe that would be really good to implement something similar here. And we do have, I think, all the elements, okay? The last one I was going to talk about is it's Rich Grow, but that I think Kim already spoke about it, that the guys in Jendicott, I think they are very brave because they were the first ones. They went through a very long process for approvals for this. They had probably 6 years until they got everything together, and including the agreements for off-taking the energy with Western Power and everything. So they are really visionaries by implementing that. And they are operating in Jendicott. At the moment, they have a bit of an issue disposing the biofertilizer, like what they produce after the digestate. And that's why when we are talking about our solution, is going beyond that and is producing a real fertilizer that you can commercialize and pack it and bag it and sell it instead of being just a liquid form, right? So basically, these were the things I wanted to talk you guys through. We are supposed to go for a coffee break now. I don't know if the food has arrived. Maybe Haley can have a check that. Okay, but we can have some questions and answers for now. Yeah.
Can I just answer that? The vehicle gas is completely substitutable for other gas.
Yeah. Yeah.
It's just like using one form of
Yeah, the burners have to be adapted for that because the amount of oxygen it needs, it's different. But I mean, once you have that multi-use burner, you can use both gases.
I'm really attracted to your idea of producing a gas as a vehicle transport fuel.
Yeah.
Because that's our biggest emissions down here is transport. My concern is if they fuel up down here with our biogas and then travel to wherever they're traveling to, how do they refuel? So they would need to refuel with a different type of gas.
Yeah.
And is it compatible?
Yeah, so the vehicles are made for that, for both gases, yeah. And you're probably going to have here a mix between natural gas and biogas anyway. I don't think you can fully fuel the freight here with biogas.
Yeah.
So, yeah, exactly. Yeah. Which I find is a really good way to do it. Because when you produce electricity here, there are two things. One, you have a loss, like half of energy is wasted as heat, right? And the second one is the value that you can sell that electricity is very low because of the electricity agreements, right? When you want to put that on the grid, you get really almost nothing for it.
Yeah, and we don't need it.
Yeah, exactly. Yeah. So I always encourage that you use the biogas for heat purposes, for fuel, for like straight away. The other thing it's possible, and it is happening at Watercorp in Woodland Point, is to produce hydrogen from the biogas. That's what the guys in Hazer Group are doing there, which is then the other extreme between using because now everybody's talking about hydrogen. There will be lots of hydrogen fuel trucks. This can be another option. You can go up beyond and above the biogas and get to there. They are all possibilities. Yeah. Anybody has another question, even to myself or to Matt or to Kim? Steve?
Could you go back to the bar chart?
Yes. I love this graphic as well.
Yeah. Right. So what was the reason for that change? Was it policy by government or was it the actual operating looking for more people?
So the change was they had just purely the abattoir waste, mainly. That's the blue bar there, right? And then they started receiving and having demand for different types of waste. So you see the pink bar, like purple bar, is more food waste. So there is, the abattoir waste is very concentrated in nitrogen. So the process gets a little bit slower. And also there are very high chain proteins. So when you put more food waste, more carbohydrates like alcohol or sugars or things that are easily degradable, the potential of produce energy is a lot higher, or biogas is a lot higher. So the combination between different wastes, that's what gave it. And it's just purely commercial. They were operating and they kept increasing. And then, that's how they achieved that. People.
Just wondering about you worked on something
Yeah, so there is a feeder, which is, there is a conveyor for the solid parts of it, which is the food waste, some of supermarket waste. There is a depacking machine as well. And there is a liquid part of it, which is like pumped, right? So then you mix both of them together in a large tank, kind of, I have here, the one in the left there in the red, right? And then from there, everything mixed like a pulp. So you probably have a macerator pump before, make everything like chewing it before you put it in the stomach, basically. And ideally, you need to have waste analysis and not just check anything and everything there. You can shock load the system. That is a delicate operation to do that. So what we normally do, we have a balancing tank prior to that, which is a 24-hour mixing where you can measure pH, measure what's happening there prior to feeding the digester, right? So it's you don't need a PhD around for operating that. Yeah. Anybody have another question? Yeah, so the other interesting thing I believe is it's how these projects can come around, right? It's not necessarily has to be owned by Watercorp or by the city of Albany or by private sector. It can be a collaboration. It can be, you can have shares, you can have different models of ownership. You can have a private operator running it, like a build own operate contract. So it doesn't mean that you have to come up front and put $10 million and or whatever, 20 to have something like that. You can innovate also on the model on how to do that, right? So that's how I see the synergies operating better, right? And then when I talk to the abattoir industry, for example, there is a lot of pressure now for them to improve nitrogen and phosphorus removal from the waste streams, right? That's because of environmental issues. We cannot anymore load the environment. But upgrading all these treatment plants is going to end up generating more sludge because we're going to move away from pond treatments and we're going to start using more intensive energy engineered reactors, right? So from there, you're going to increase the production of biosolids as well, which is like an elephant in the room for wastewater treatment at the moment. So what do you do with biosolids? When I studied back in the 90s, it was saying biosolids for disposal, but that's not anymore the case, right? So we need to think of how we're going to integrate that and how we're going to really become sustainable. And that's where I see putting it all together, right? Okay, so.
Question, Fabiana?
Yes.
It's Matt Deegan here from AMPC. Thanks for that. Good presentation. I'm just wondering on the scale for AD, and Rich Grow's the faithful example that we often cite. It's got 50,000 tonnes of feedstock there, and with commercial and industrial feedstock available there. What examples do you know of that might be a smaller feedstock availability than that? Are there any in Europe or Australia, or is that as a case study, is that this sort of like the smaller side that we look at?
Well, we can, in theory, we can do anything above 1 megawatt is feasible. So that means it's about 1/3 of Rich Grow size, but there is no one in Australia doing that small size.
Right.
That I'm aware.
Is that because of the financial situation? The feasibility is less attractive. Yeah,
it is, especially if you are calculating your feasibility based on energy, on electricity. If you're not using the gas as a fuel or as a heating component, that gets really complicated, because then you need to run a CHP engine and you lose a lot of efficiency there. And then you have to have a trade agreement with the grid operator, which that's normally where you lose a lot of competitivity. And that's the thing, right? But if you use, for example, I'll give you an example. When that was probably 15 years ago, I went to India looking at digesters, and there was a small orphanage. They had about, I think, 300 orphans there, and they were running a biodigester from their food waste. I don't know if you know, but in India, they never reheat the same food. After they prepare a meal, they throw away whatever is left and they cook a new meal. So there is a lot of leftovers like rice, lentils, like organics. So in this orphanage, the students were running a biodigester in the backyard, and they are producing all the cooking gas for themselves from the digester. So that's very small scale, right? Just scraps from lunchtime from the boys, and there was a 14-year-old guy operating it. And that was like a beautiful example from very simple, small system, right? In Brazil, we have there are stuff you can put in your backyard that you can do and run a generator from there, or use the gas as well for cooking or for lighting the streets and all these things. So depending on how you're going to use the energy. I have a question here from Peter Spencer. I'll have to get closer to see it. Oh yeah, Peter Spencer from Water Corp in Perth. He was asking exactly about the idea of producing hydrogen from methane. So yeah, Peter, I think that's one of the alternatives. I think it's going to be good to have the Woodman Point project there proven, and so people get more confident on how that's happening and what's the byproduct, that's the graphene, how that can be used as well, right? And I believe after that trial will be very, very interesting to think about that as well as a hydrogen. Yeah.
I actually had a question on that as well, Fabiana. Or is there another question from the audience you want to take? Or
people was going to ask a question here, so.
Yep.
Oh yeah. Okay. As I understand, they are in construction phase, and they are going to. Just want to close it, and they are going to commission that, I think, early next year, but it's going well. So Matt, what was your question?
Oh, sorry, the hydrogen aspect, is that via steam methane reforming, is it? You take the methane and reform it using steam into hydrogen? Is that what you're talking about?
No, this is more about pyrolysis, really.
Right, okay, thanks.
Yeah, I don't, I'm not very, sorry.
Yeah, be interested to see that. It's still using an energy source and pressure to through pyrolysis.
Yeah, you have to, yeah. And the idea is as long as the end product is carbon positive. I mean, if you don't use more energy to produce that, then you're going to get it in the end, right?
Yep.
Okay.
I did have another question if there's no others.
No, go for it. Go.
Sorry. Treating of nutrients and nitrogen and phosphorus example in wastewater and treating that. Is that a trade-off on the energy aspect of, recovering biogas, or is that one versus the other, or can they be done together feasibly, or what's your view on that? It probably depends on the amount of feedstock, I guess, and the characteristics of it, but
yeah, I think it's always case by case, because it depends on the distances you have to transport the waste, depending on what the uses are for the energy as well, right? So that's why we always have to have a feasibility study done before we decide exactly what we're going to do. Yeah.
Yeah, good one. Got to start with a good feasibility.
Yeah, that's always the idea, right? And the feasibility has to be not only financial, right? It has to be also environmental. So are you creating a worse problem by doing this, for example? And that's something I question myself when we are all blindly going towards hydrogen from seawater, right? So what's behind that? You have to have a reverse osmosis there. Then you have to have a demine plant afterwards. You basically need to double the water supply of Perth now to have a hydrogen plant running to provide electricity. And then you have a brine that's basically more water than what you use, right? That you have to dispose into the ocean. And what's the impact on that on the environment? So all these things, we cannot just rush and think, oh, this is the holy grail, right? We need to look at all aspects of what we are defending and what we are going for. I'm not against it, but I'm just mindful that we need to consider all these things, right? And then people say, oh, but that's going to be run by renewables. Well, if you have a large desalination plant, and the technology providers here in the rooms know that, you cannot stop it. You have to run it 24 hours. So tell me, what's your renewable now? Is it a solar? No, because you have to turn it off at night. Is it wind? No. So how are we going to balance that? And that's where maybe biogas can be part of the matrix, where when you don't have sun, you don't have wind, you have biogas stored. And then you can use the biogas as a battery for the periods where your other renewables are off, right? So how you can combine all these things together in a matrix to make things really sustainable. And that's a lot of conversations, a lot of thought, a lot of, I don't know the answer. There is yeah.
I have a question about this plant in recovery. So effectively, what was happening is the system was not designed at the very beginning to do co-digestion.
No, yeah.
They basically started feeding, and then it now is a self-accommodating variation of feedstock. So like it can completely change the trend, and then still basically functioning.
Yeah, this was designed to treat an abattoir waste. And in the end, this became a company by itself. So it got detached from the abattoir, and it's run now as a business independently that gets the wastes from the abattoir and from other.
What is, there is like a battery limit then in the field?
Yeah, they have a maximum of 125,000 tons. They are now running at 100,000 tons a year. And that's because of the hydraulic retention time. You need minimum 30 days in a reactor like that. So if you feed much more volume, and then you cannot get the retention time.
You know what really battery limit
yeah, as long as you have carbon, nitrogen, phosphorus, things that you can digest. You cannot put oil there or put stuff that are going to kill the bacteria, right?
And then how do you control the feed?
Or they analyze before they accept any new stream. They analyze it. They know how much methane, the biomethane potential of each feed, and then they combine. Let's say if they have a big batch of something really strong in carbon or really strong in nitrogen, they'll dose it slowly. They're not going to put everything at once. They do. Yeah, they have it. Yeah. Okay, yes.
So I've just noticed that the actual abattoir waste has decreased since its peak. What's the reason for that?
Yeah, I don't know the details about why. Maybe probably what happened is a trend across all the abattoirs. There is more rendering happening, so they are recovering fats for other uses. And maybe you guys from the abattoir can tell me why these kind of things happen. There is more recovery from products, right, Peter? Yeah, happening. Yeah. So probably that's the trend. Okay, so if we don't have any more questions now, we can go and have some food that's ready there. Kim, Matt, guys online, we'll be back here at 10:30, okay?